So basically, I will be dealing with class 10 maths today. This is the part 1 of real number. This is the first chapter of your syllabus is real number. So basically, before going to real number, let me describe you a few of the other things like what is a natural number. Natural number are those if you start from 1, you do not consider 0, start from 1, 2, 3, 4 and up to, if you go on infinity in the positive side, that is your what natural number. Now when I tell about whole number, what is a whole number? If you consider 0, 1, 2, 3, 4, these are all what whole number, right? So there after that comes integer. Now integers are which number? Suppose you are starting from 0, 1, 2 up to infinity, and on the negative side -1, -2 and infinity. So all the numbers are said to be integers. Okay, so integers are divided into two parts. One is your positive, one is your negative. So the positive integers 0 to right hand side and the negative are left hand side. So what is a rational number? Rational number is basically, we say generally in class 9 we got the numbers which can be represented in the form of p by q are called rational number. Now what is p and what is q? P and q both should be integer, right? Now what is a rational number? Suppose you consider a number line. Suppose this is your number line 0, 1, 2, 3 and infinity, and here -1, -2 and minus infinity. Okay. Now if I tell you what is the next immediate whole number after 1, so you will say that it is 2, because after 1 and between 1 and 2 there is no whole number or natural number. If I tell about integer also, that what is the next immediate integer after -2, you will say -1. So in between -2 and -1 there are no integer. Okay, but if I tell about rational number, suppose आप अपने आँख बंद करके कहीं पे भी तुम वो पुट करो, suppose there, okay, against this you will get a number, okay, maybe 1.5. Anywhere in the number line you put the marker, wherever you get there definitely be a number. Now the question is what is the next immediate rational number after 1? So when I say rational number after 1, it can you might say 1.1, yes, one might say 1.01, one might say 1.0001, or maybe 1.000, infinite number of zeros and 1, say 1 lakh zeros and 1. Okay, so all these number you can represent in the form of p by q. P by q in the sense is 1.1 can be written as 11 by 10, 1.01 can be written as 101 by 100. So basically this is your p and this is your q, right? So these numbers are called generally rational number. So what is then the chapter is real number. Then what is a real number, right? So there are some number which are not in the number line. Okay, they are in the number line but they are not rational number. Now which numbers? Suppose you consider those numbers. Suppose 1.000523001 and so on. So see here basically what happens, you know, right, the digits are ending, okay, but here the digits are not ending, right, they are going on. So if you do not know the end digit and looking at the pattern you don't know what is the next number, such numbers are called what? Irrational numbers, right? What is the irrational number then? Suppose, see, numbers are divided into two parts, okay, decimal numbers are divided into two parts. One is your terminating decimal number, terminating, and one is non-terminating. Okay, so in case of terminating it is divided into it is not divided, sorry. So terminating means what? 1.05, 1.23, 10.43, these are all what? Terminating rational number, because they are ending with this is the ending digit 533. Okay, but when you talk about non-terminating, that means There again comes two parts. What are the two parts? Can you tell me? Yes. So there are two parts. One is your uh, repeating and non-repeating. So the numbers which are non-terminating and repeating. Suppose 1.232323. These numbers you have already got in class 9, and that is 1.23 bar. So this is what? This is also a rational number. This also falls on rational number, although it is non-terminating. But non-repeating is what? Suppose 1.23, 27, 29 in this way. By looking at this pattern, you cannot say what is the next number, right? So these numbers are called non-terminating, non-repeating. Okay, and such numbers are called irrational number. Irrational number. Okay, so basically what we can conclude, that irrational number is what type of number? Irrational number are what? Which cannot be represented in the form of p by q, which are not represented by p by q. Why? Because we do not know the ending digits, so we cannot express it in the form of p by q. So give me some examples of irrational number. We know root 2, root 3, pi. These are all what? Irrational number. So in the last part, what did I explain? Rational and irrational number. Now it is very clear to you what is rational and what is irrational, right? Now this combination, now rational numbers are those which can be represented in the form of p by q, and this cannot be represented in the form of p by q. Okay, so the combination of rational and irrational, we call it as a real number. Real number. Okay, now this is what the chapter is all about. We will discuss both the rational number and irrational number. So rational number, I believe you have completed in class 9, but this time we will be dealing with how the irrational numbers are there in your book. Okay, so first thing that is there in your book is Euclid's division lemma. Euclid's division lemma or algorithm, whatever, both are correct. Okay, see your page number 2 or 3 in your textbook, you will get that there is a theorem called Euclid's division lemma. What does this lemma state? Given two positive integers a and b, two integers are given a and b, small a and small b. Okay, there exist unique integers q and r. Another integer q and r exist for given numbers a and b, such that it satisfies the equation a equals to bq plus r, where the value of r lies between 0 less than equal to b, 0 less than equal to r less than b. Now when I say, when the question comes in the exam, you have to make sure that you write this one, otherwise you will not get marks, because there are two numbers a equal to bq plus r, where r lies between 0 and b. Now just for explanation, you just understand, suppose you take a number a and b. Suppose a equals to 5, b equals to 2. Now if I divide 5 divided by 2, 2 to the 4, you will get 1 as a remainder. Yes, so a equals to, so instead of a, what I can write, 5 can be written as 2 multiplied by 2 plus 1, 2 multiplied by 2 plus 1. Yes or no? Yes. So that means what? If this is our a, if this is our b, see, a equals to bq, so definitely it must be our q. And what is r? R is 1. Clear? So Euclid's division lemma was basically used to find the HCF. Okay, that I will be discussing later. Just you have to understand what is this. Okay, now what is this condition? This is the important part. 0 less than r less than b. See, the value of r is what? 1. 1 is obviously it is lesser than 0 or greater than 1, greater than b. Now what is b? 2. Okay. Any value you take. Suppose you are dividing 12 with 2. 2 6 are 12 and it is remainder is 0. So the remainder r is 0, which is equal to 0. That is why it is given 0 less than or equal to. So 0 is equal to 0 and it is definitely less than b. What was b here? 2. Okay. So suppose you are dividing with 3. So 3 4s are 12. Again same thing. It is 0 equal to 0 less than your 3. Okay. Suppose if you take 5, 12, 5 2s are 10, remainder is 2. So what is the remainder? 2. 2 is less than 0 definitely, yes, and it is lesser than 5. Okay. So basically what I am telling you is that, see, the value of r always has to be greater than 0 or it can be 0 remainder, but it cannot be more than b. That means more than 5. If you take any number, this number is always greater than the remainder. Okay? Is it clear? Suppose you take 3 I have taken, take 4. 4 also it will be same. 4 3s are 12 only, it will 0. Okay? 5. If you take 6, if you take 7 also, see, 7 1s are 7. So that means it is 5 again. Yes or no? So whatever you take, you are getting the remainder that is definitely smaller than this. If you take 3, then also it is it is lesser than this 2, all the time. Okay. So you keep in your mind that r should be always lesser than b, and this theorem can be used to find the HCF of two numbers. Hello again. So before going to the next part, let me explain you what is HCF. Now, what is the full form of HCF? Highest common factor. Okay, let me start from the scratch. Now, what is a factor? You tell me what are factors. Suppose I want to find the HCF of 6 and 12. Let us assume. So factors means what? Basically, when you factorize 6, 2 3s are 6, 3 1s are 3, and when you factorize 12, 2 6 are 12, 2 3s are 6, 3 1s are 3. So basically these are called the factors, right? So it's when you consider 6 can be written as 2 into 3 into 1, and 12 can be written as 2 into 2 into 3 into 1. Okay. Now see, these are not the only factors, right? Now what another method I am telling you is that these are the factors, fine, but highest common factor, right? It has to be highest. So what I can write from here, 6 can be written as 1 into 6, 2 into 3, and nothing else. Yes. 12 can be written as 2 6 are 12, 1 into 12, 3 into 4, and nothing else. Okay. So these are all the factors. That means when you divide these numbers with 6, that means you will get 0 as the remainder. Okay. Now among this, which is the highest factor? Here what are the factors? You tell me the factors. 1, 2, 3 and 6. 1, 2, 3 and 6. Here 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 6 and 12. Right? Now these are the factors. Out of this, which is the common factors? Common factors is 1 is our common factor, 2 is a common factor, 3 is a common factor, 4 is not there, 6 is a common factor, right? So among these factors, which is the highest? 6 is the highest. So what is the HCF? Highest common factor is 6. Okay, so this is the basic idea what is HCF, right? But we will be using Euclid's division lemma to find out what is the HCF of 6 and 12. Okay, now let me take an example. Suppose it is there in your book, example 1. We have to find the HCF of 4052 and 12576. Okay, so basically how will you apply? So I am writing the lemma one more time here. A equals to BQ plus R. This was our lemma, right? So this can be, see, this is a smaller number and this is a greater number. So obviously when we divided 5 by 2, so this was our A and this was our B. So the smaller number has to be B and the bigger number has to be A. So first you will take this one as A and this is our B. Now when you divide this one by this, so that means we have to divide 4052 divided by 12576. Yes, so I am writing from the book, it will be 3, and when you do the calculation the remainder will be 420. Okay, here 3 into this will be the answer here and the remainder is 420. So what is the formula? A equals to BQ plus R. So A means what? 12576 will be equal to 4052 into 3 plus the remainder 420. Now the catchy part, the next part is we have to keep on using this algorithm until and unless the remainder becomes 0. Okay, so what happens now is this will be our A now. So 4052, and what is B? This remainder will be our B now. Okay, 420 into, now that means what? We have to divide this by 420. So 420 has to be divided with 4052. Sorry, 4052 has to be divided with 420. So when you divide, we will get 420 ones are, and when you do this part, this will be 9. Okay, whatever is the answer, here you will get the remainder as 272. Okay, so it will go with 9 plus 272. Okay, again, is the remainder 0? No. So we have to do the same thing. Now 420 will come in this side. 420 has to be divided with 272. Okay, so divide 420 by 272. Now when you do this part, I am not going to write into details since you have understood, I believe. This, if you divide by 1, then the remainder will be 148. Did you understand or not? Yes? If you don't understand, just pause it and see it from the beginning again, you will understand. Okay, so here also the remainder is not 0, so we will continue in this way. So now 272 will come, that has to be written with 148 into something plus something. So into something means what? This when you divide with 148, that will go with again 1 and the remainder is 124. Okay, again it is not 0, so again 148 can be written as 124 into something plus something. So into something means what? 124 into 1 again and the remainder is 24. Now since I have no space, I am writing it here. Again, is the remainder 0? No. So we will consider doing the step next time. So 124 can be written as 24 multiplied by something plus something. That means 124 has to be divided with 24. So 124 and this will be your 5s and the remainder will be 4. Again the remainder is not 0. So again 24 will come here and 4 will go there. So 4 how much is 24? 4 6 24 plus 0. Okay. Now since the remainder is 0, we got remainder equals to 0. That means our steps are completed. Now we have to find that what is the HCF. So basically you will remember the B will be the step where the remainder is 0. The B will be your A equals to, this is A equals to BQ plus R, where the remainder is 0. B will be your HCF. Do not think that the remainder itself is a HCF. No. So what is the HCF? HCF will be 4. So that means what we can say, HCF of which numbers? 4 0 5 2 and 1 2 5 7 6 will be equal to 4. Did you understand this part? If you don't understand, just repeat it and recheck, you will understand it. Okay? So this is how the Euclid's division lemma is used to find the HCF between two numbers. Okay? So for this class, I will suggest you homeworks which you have to submit. Homework is exercise 1.1, question number number 1, all. 3 questions are there. Okay? So I am writing the question. If you don't have the book, I will send you the photo. Still, you have to find the HCF of these numbers 135 and 225. Number 2, 196 and 38220. This will be a little tricky, so you have to be very careful. I mean, you have to go on searching which number it will be divided by. Number 3 is your 867 and 255. Okay?